Hi there, this video is going to be a walkthrough for the Build a Molecule Simulator assignment. I'm going to start off by going through the general biology classes assignment, and then at the end I'm going to add a add-on for the AA assignment, which was a little bit different but had some similar parts. So follow along with me for parts 1 and 2, whether you're in general ed or AA, and then at the end of this video I'll go back and hit the AA sections that are different from the general ed assignment. So for starters, you want to have this assignment open. It is in the week 3 folder for general ed and the week 2 folder for AA. And open this up. The first thing you're going to do is you're going to click on the Build a Molecule Simulator and then open that up so it looks like this. So you're going to make sure you hit the single button on the bottom or here, and this is where you're going to start. So once you have that open, you can come back and we can answer these questions. This question we went over in class, what is the difference between an atom and a molecule? You can use your notes to look up what an atom is and then take your best guess at a molecule. The only way you can get this question wrong is if you Google it or you don't give me the sentence that I asked you for. Okay, so it's very easy just to try. Remember, we need to try in this class a lot, even though you don't understand. I want you to take a guess and give it your best effort. So part 1, all right? So we go over what a atom is and what a molecule is and the definition. An atom is the smallest group that something can be divided into, and a molecule is a group of atoms chemically bonded together. So we're going to focus on that for this assignment. So once you have this opened up, these are instructions here for how to get set up and what this is. So when you get to the first home page of the PhET simulation, you should see hydrogen and an oxygen tub with little spheres in there that represent the atoms that you're going to use to make the molecules. You're going to be able to scroll through different sets using the bars that are highlighted in red on the left and the right. And then you can also see the collection that you're trying to make on the right-hand side in the yellow box. That's what you're going to be trying to make. You're going to need to be able to take screenshots in this. So this is the 100th time I've gone over this, but this is how you take a screenshot. Hold down Windows, hold down Shift, and hit S one time. Your screen will go gray, and then you'll use the mouse to click and drag to capture whatever is inside the box. Then you're going to use Control V to paste it where you need it. So I'm going to go over that today as well. You'll see me use that skill. So if you forget, this is how you do it. So starting with collection 1, all right, the formulas are listed here on the side. And you're going to try to make this molecule. You're going to list the name, the number of elements that occur, the number of atoms that are there, and then you're going to do a screenshot. If you're doing this on paper and you're watching this from your phone, then you'll need to draw what you see to the best you can. I know this is not art class, so if your drawing is not super awesome, that's okay. All right, so let's go ahead and make this first one. So you have H2O, so you can go ahead and piece through here, and you're going to be able to drag and drop these atoms and attach them to the oxygen. When you make it correctly, you'll see that it flashes up in the top corner, and it'll have an arrow where you need to drag and drop it at. So I'm going to click and drag and drop it in the box here. When I get it right, it'll make a ding, and it'll highlight that box in yellow. So next, you're going to go through and you're going to continue to make all of the other ones. So you're going to make oxygen, hydrogen, carbon, and nitrogen. But first, you're going to check out the 3D model. All right, so this is what I want to see, this model. Please make sure it's facing so you can see all the atoms in the molecule. And if you do something like this, you see I rotated it so you can only see 2 of them. That's incorrect. You need to be able to see all 3. It does not matter if you use this one or this stick model. That's fine with me too. So it does not matter which one you use. If you pause it, it's a little easier. So up top, you have the element name, so water. You have the formula, H2O. And then you have the picture that you're going to take a screenshot of. So I'm going to start by taking a screenshot and then go back and fill in all the boxes. So Windows Shift S, click and drag to capture my molecule. It will go right to my clipboard, and then I'm going to come here and paste it here like you would text. So Control V, and boom, there it is. Now we're going to walk through it. So it said the name of this the name of this molecule was water. That's pretty simple. Okay, water, the number of elements. So each element is represented by a different color sphere. So you have a gray sphere and you have a red sphere. So you have two different colors. So you have two different elements. So you have two, all right? So the oxygen in red, the hydrogen is in white. So now the number of atoms is the total count of the spheres you see in your picture. So I see 1, 2, 3. So I have 3 total atoms. And that's how you do it. So I'm trying to get you to understand that there is a connection between this formula here and the elements and the atoms that show up there. You can have one molecule made up of 2 different elements with a total of 3 atoms. So down here, you're going to keep doing the same thing. All right, so I'll do this one. So O2. So notice how I ran out of stuff here. All right, if you click the over on this box, it'll take you to another screen that has more elements to choose from. So I need O2, which is molecular oxygen. So I'm going to drag this up, drag this one up. So it's just O, and there's a little 2. So that should be a hint that there's 2 oxygens together. So if you get these 2, click. All right, there you go, molecular oxygen. Drag and drop it over there. If you ever realize that you've made a mistake, you can click on this blue box and it'll separate the atoms and you can try again. Now I'm right. Hit 3D. All right, and then there is my bond. Windows Shift S. Take my screenshot. Come back to my assignment and paste. All right, and as we saw, this is molecular oxygen. You got from the title in the white right here, molecular oxygen. So in this, I only have one color. I only have red. So it's just one element, and that's oxygen. Oops. And then I have 2 of those oxygens bonded together, so that would be 2 atoms total. And that's the name of the game for part 1. You just create it and then fill in those boxes, okay? This one might be a little bit tricky down here, CO2, but I think you can figure it out. Build it, drop it, screenshot it, come back here. And that's the end of part 1. For double A, there is a second part to part 1, and I'll go over that at the end of this video. So that takes us through the end of part 1. So now we're going to move on to part 2. All right, so in part 2, you're going to have to click on the multiple tab at the bottom. I have that in big green letters so you can't miss it. If you try to do this in the same tab you did part 1, you'll be very, very, very confused. So I'm going to go here and go to the bottom where it says multiple. Okay, and you should see your molecules and you should see the collection change here. So you should have 2 CO2, 2 O2, 4 H2, and 2 NH3. So the first 2 questions, we did this in class, but in case you weren't there, this is going to be what I'm going to take a concept you learned, I don't know, in like what, 5th grade, how to do math like this, and I'm going to add it into the chemistry, what we're doing. So it's a concept you already know how to do. I'm just going to show you how it applies to molecules. So in math, 2 in front of this 3 plus 1 is saying that there are two separate 3 plus 1s. So there are two groups of 3 plus 1 together, which you add together and get 8. 2 times 1 makes 2, plus 2 times 3, which is 6. So 2 plus 6 is 8. So that's what the 2 in front of the parentheses means. It means that there's two groups of 1 plus 3. With that in mind, number 2, is this equation the same as in question 1? And yes, it is, because 1 plus 3 makes 4, plus 1 plus 3 also makes 4, total of 8, which is the same thing you got in the other one. But it's not the same based on the answer. It's the same because it's saying the same thing in a different way. It's expressing 2 times 1 plus 3 in a different way. It's the same thing, it's just in a different way. So that's what you should be writing down for number 2, something along those lines. Because it's the same thing in a different way, and I want you to really understand about this too, is we're going to go and we're going to do this collection. So make sure you really grasp onto that the 2 in front says that there's two 1 plus 3s. So keep that in mind when you go into this. So here are the chemical formulas over here. These are incomplete. All right, they do not have everything I want in them. I gave you the base formula, and I want you to put in the goal. All right, so this is the goal for the chemical formula. So here I want to make this goal. So if I go over now to the build a molecule, I can see the goal is 2 CO2 for this first one. So just like we talked about in the questions 1 and 2, the 2 in front of that 1 plus 3 meant that there's two groups of 1 plus 3. The 2 in front of any chemical or molecule tells you the same thing. There's two CO2s there. So I want to go and I want to go back and I want to make sure this says 2 CO2. So the name of that molecule is the same thing. All right, so we're going to go scroll over till I have a carbon. I'm going to drop my carbon. And I'm going to have O and O. I made carbon dioxide. And this the box flash with the arrow. I'm going to drag and drop this over here. Pop. There you go. So you see that you have two indicators. One of your goal in bold, and the second one is what you have currently in the black box. So you currently have one CO2 molecule. So if I want to make 2, obviously make another one. So I'm going to drag carbon up and make the same molecule a second time. Drag this over, and as you hear, you got the check sound. So it's highlighted in yellow, means you did it correctly. You have 2 CO2 molecules, which is exactly what you're looking for. So this is what I want you to take a screenshot of, is this 2 CO2 part right here. I'm going to take a screenshot of that. I'm going to highlight all of this and took a screenshot. So we have made carbon dioxide. So even though you have 2 of them, it's still the same name. It's carbon dioxide. So carbon dioxide. The number of molecules I have is 2, because I have, if I go back, I have 1, 2 molecules of carbon dioxide. So remember, a molecule is a group of atoms bonded together, and I have 2 groups. So I have 2 molecules. The total number of elements is the number of colors again. So it's a little bit of what we talked about up in part 1. So I have 1, 2. I have a red representing oxygen, and I have a gray representing carbon. So even though I have 2 molecules total, I only have 2 elements present. It's just repeated. So I have 2 elements. However, this is where it gets different from what we did before. If I have 2 groups of carbon and 2 oxygens, That would be like saying two groups of 1 plus 3. So if I have no little number next to my symbol, that means there's an invisible 1 down there. So that's only saying I have one carbon present. And if you look at my molecule, that's true. There's only one carbon present in this molecule. But I have O2, which means I have 2 oxygens. So I have a total of 3 atoms in this molecule. But it says before that I have 2 total molecules. So 3 times 2 is 6. And I'm going to paste my screenshot in there. I want the screenshot of both of them so I can see that you did it. Okay, so let's try this one. So again, O2 is not the goal, H2 is not the goal, and NH3 is not the goal. I want you to write in the goal. So I'm going to do 4H2. I'm going to skip down one. All right, so my goal is 4H2. So I want a 4 in front. So please make sure that you have these in there. I'll be looking for them to make sure that you wrote them down correctly. So 4H2, if I build an H, so let's go over here where there's a bunch of hydrogen. I have 1, 2 hydrogens, okay? I have a second. All right, so as I drag and drop them over, you can see that I have now 1H, 2H, all right, but I'm not to my 4 yet, so that means I have to make 2 more. And you see how it tells me with the arrow where to go? Drag and drop it in there, and I'll make 1 more. Boom. So I have 4 H2s. That 4 means I have 4 of the following molecule to make, and that's what I want to do. Screenshot this and take it over here, paste it. And now you can go through again. So the name of it was molecular hydrogen. The number of molecules I have is the same as the number that comes in front. And this number is called the coefficient. So I have 4 of those. Total number of elements is only 1 because there's only hydrogen. There's nothing besides hydrogen. There's only one color you can see in there, and that's that gray, which represents hydrogen. And then the total atoms, if each molecule is made up of 2 atoms. And I have 4 groups of 2, all right? So just like we did in question 1, where this 2 up here meant that there are 2 groups of what's in parentheses, that's exactly what this number means in front. There's 4 groups of what comes next. So 4 groups times 2 is 8. So hopefully that will help you be able to finish the rest of it. Number 3, it says by now you should be able to answer the following questions. If you don't, do another collection and pay attention to the following. What does the 2 in front mean? I just talked about that. The 2 means that there's 2 groups of the following. And the little numbers down here are called subscripts. That means that there are, whatever the subscript is, that many of the element that came before it. So there's 2 oxygens bonded to 1 carbon. And then I want you to come back and I want you to restate your understanding of a molecule. We talked about that earlier. In the first question, I asked you, what is a molecule? What do you think it means? And I want, now that you have seen it, played with it, I've gone over it in class and told you what a molecule is, I want to see what you understand. Please make sure that you take special attention to give me a complete sentence. You will not get credit if it's a complete sentence, and you will not get credit if you Google the answer and paste it in there. So please give me what you understand from this assignment. So if you're in the general ed classes, that's the end. Once you get through all of it, feel free to submit it. But if you're in my AA class, we're going to move on over to your assignment and go over the stuff that you missed. So again, if you're in general ed, you're done with this video. If you are in AA, continue watching for the end. So in the end here, we got, let's see. So where yours is different was right here. All right, so we're gonna go back up to part one, was this arrangement of molecules. So have you noticed that the molecules only work in certain arrangements? All right, when you play with this, you should notice that that is true. For example, if I go back to single, let's go here, and let's do carbon dioxide, all right, like you've done. Oops, let me do it again. All right, so if this is carbon dioxide, which is over here, why doesn't carbon dioxide work when I do it like this? It's still carbon and two oxygens, it just doesn't work. All right, so it's because of the polarity of each atom, which we talked about in class, but just this exercise shows you that not all arrangements work, and they work in certain ways based on the electrons and how they're arranged in each atom. So if you come across something like this would be a good one to use for ones that doesn't work. So over here where it says find an arrangement, it's unacceptable. All right, take a screenshot of this, and then take a second screenshot of when it does work like this. So this would be the acceptable arrangement, and this would be the unacceptable one. There's several more that you can do, all right? So try not to use this one with carbon and oxygen. There's a bunch of other ones you can do. Let's see if I do like this. So you see how it doesn't let me do two O's in there, but if I arrange it like this, the H doesn't go down here, but if I arrange it like that, I get a different molecule. So that's kind of what I mean is like some of the arrangements don't work or they don't come up with anything, and that's what I want you to play with. So that's part two. I'm sorry, question two, part one. Make sure you put the molecule you chose and put in the appropriate screenshots. Going down to the part three for the AA assignment. All right, it says click on the playground tab at the bottom of the window. So try to build the largest molecules you can. So this is kind of one where you get to play and you want to build it as large as you can with as many molecules as you can that still gives you an actual name of a molecule, okay? So if I go to playground at the bottom, playground, right, you have a lot more to choose from. You have hydrogen, oxygen, carbon, nitrogen, fluorine, chlorine, silicon, boron, sulfur, phosphorus, bromine even. All right, you can go all the way over here and make what you want. Notice how there's a lot of carbons and a lot of hydrogens. It's like that for a reason. So you can try bonding this stuff together and just messing around. And then, like I said, just play around and see how big of a molecule you can make. All right? So this is an example of one that's a little bigger, but it's not the biggest. Right? You can cut specific ones by clicking on the element you want and then clicking the scissors, and then you can try again. So again, I'm just playing with carbons and hydrogens is a good one to start with. So I went from ethane to propane, and again, you can keep this trend going. Try one more. Butane. So you see what I mean? Like You can just keep adding. You can cut here and maybe do like an oxygen group. So this is methanol. All right, so you see what I mean? Use whatever you want and try to make it as big as possible, right? I'll give extra credit to whoever makes the biggest molecule out of the whole class. When I look, notice, again, I think a little hint I'll give you is notice why there's always a lot of carbons and hydrogens, all right? That could be a hint. But just play around and see how you can make the biggest one possible. Take a screenshot of it, paste it here, tell me the name of the formula, tell me the chemical formula for it, and then tell me the elements in it, and then tell me the number of atoms. All right, and that's it. So again, this one's going to take a little bit of creativity and effort, mostly effort. All right, you're going to have to do some playing. There's no cut and dry direct right answer. You're going to have to try. Okay. If you have any questions, please feel free to reach out to me on Schoology or email, and I will do my best to help you. I'll skip around this video and rewatch sections if you need extra explanation. Hopefully this helps, and I will see you in class.